Good morning. Just ready hoy IndoML kan ulalu. Etia registration D block ot hoy ase. And D block konkin ase exactly gom napo. Ipine amar hostel ase. Gandhi Bhavan tate ami asilu. Tate amar single room allot korise. Etia ami jab log. Eto rati amar ahi paisu etia Google Map e বেলেগ এটা লোকেশন দেখাই আছিল এই লোকেশন অনুযায়ী আমি গৈছিলো বাট তাতে ব্লক সি চলি আছিল আৰু তাৰপিছত সিকিউৰিটি খুদিলো একচুয়ালি গান্ধী ব্লক ভৱনটো কোনখিনিত আছে তাৰপিছতে এই কলে যে হিপিনি পিনে যোৱা তাতে পাই যাবা এইটো হোষ্টেল সেকশন তো হিপিনে বাট যেতিয়া কোনোবাই লোকেশন দেখাই আমাক সেইটো দেখাই বুলি হেতে কলে আৰু যে গান্ধী ভৱন বুলি মাৰিলে এইটো দেখাই সবে ইয়াতে আহে আই থিংক গুগল ম্যাপটো আপডেট কৰাৰ দৰকাৰ হয় নাই বহুত ধুনীয়া কেম্পাছ হৈছে ফুল কোনোবা এখন নতুন ঠাইত ফাৰ্ষ্ট আহিলে অকণমান উলট-পালট লাগে বাৰু গুগল মেপত অকণমান উল্টা হয় বাট যেতিয়া আমি এদিন বা দুদিন অতিবাহিত কৰোঁ সেই ঠাইখনত বা ঠাইডোখৰত তেতিয়া আমি বস্তুখিনি ভালকৈ গম পাওঁ আৰু শ্বৰ্টকাট ৰাস্তাবিলাকো আমি গম পাই যাওঁ হয় নহয় তো যেহেতু আজি ফাৰ্ষ্ট টাইম এট বিটছ হায়দৰাবাদ বাট যেতিয়া আমি লাষ্ট টাইম IndoML গত আছিলোঁ তেতিয়া আমাৰ ফাৰ্ষ্টত অকণমান এদিন বা দুদিন অকণমান প্ৰব্লেম লগাইছিলে তাৰপিছত কিন্তু আমি এক্সপাৰ্ট হৈ গৈছিলোঁ শ্বৰ্টকাট ৰাস্তা পাই গৈছিলোঁ ইপিনে পাৰ্কিং স্লট আছে আই থিংক ইপিনে সবাই যদি গৈ আছে ইপিনে হ'ব আৰু ডি ব্লকটো আমি আহি সেই ভিতৰৰ ক'ৰবাত আহিলোঁ আৰু নাজানো আৰু কি হ'ব ক'ত বা গৈ আছোঁ বাট কেম্পাছ বিউটিফুল ধুনীয়া হয় দেই সেইটো মেনেজমেণ্ট ভাল যিহেতু ফাইনেল লোকেশন হে পালোহি এই আমাৰ ৰেজিষ্ট্ৰেশ্যন এণ্ড ইয়াতে ৰেজিষ্ট্ৰেশ্যন যে চলি আছে IndoML বিটছ পিলানি গোৱা নে পোষ্টাৰ লগাইছে এনে পোষ্টাৰ লগাইছে বোলা হে দোস্ত बोला दोस्त खगे ए दोस्त
No, we considered
কি দিছো নেকি ইবে নেকি এতিয়া আমি যাব লৈছোঁ অডিটৰিয়াম এইপিনে আছে ব্লক এই বস এদিকে এতিয়া আমাৰ IndoML এই তাতে বহ নেকি আহা
gold dangi tha bole edi ki nothing nahi
I'm Professor Mani Gupta, and on behalf of the local organizing committee, it gives me immense pleasure to warmly welcome you all at the Pilani Hyderabad campus. We hope your time here has been great so far, and we are confident that the next 3 days are going to be an enriching experience for all of you, filled with insightful discussions, meaningful learning, networking, and collaborative exchange of ideas. To formally kick off the proceedings, I would like to invite upon stage Professor Snehanshu Saha, Professor at Pilani Goa Campus, Head of AppCare, and the Journal Chair of IndoML 2025, to please come upon the stage and present an overview of the origin and the journey of IndoML.
I had no idea it would be this chilly coming from Goa. But nonetheless, very good morning all of you. Thank you for being here. I'll be brief in just describing the history of IndoML started in 2020. This is the 6th edition. And the first few editions, because of COVID, happened online, but then we started organizing those across campuses. Last year it was at Pilani, Goa. You come to think of it, there is no immediate tangible benefit of participating in IndoML in the sense that it's not a standard conference. You don't come here and present your papers and get a certificate out of it. So such things don't happen here, and that's precisely the point. That the idea is to build a community of machine learning where we try to support students in both graduate forums and undergraduate forums. By the way, this year marks the inauguration of the undergraduate forum, and later on when Monojit presents the individual forums, you will get to hear more about it.
Upanishads or Vedas or someplace like that, there is a saying that Brahmachari's mind is not a pot to be filled, but a fire to be kindled. And I can find no better example of that than the IndoML Symposium here, which is not a symposium in its or a conference in the traditional way of things, as Professor Sanchi said, but it is a meeting of exchange of ideas and exchange of ideas with youngsters who are going to carry this branch of knowledge and this branch of application forward into later this century and into the next century maybe. Frankly speaking, I am a little afraid of ML and AI and all these things. And I guess I'm not an exception, particularly being a layman in these terms. I do not know whether I am going to have a job in the next. I don't have my job very longer, but whether my offsprings and their offsprings are going to have jobs is a big question that is looming large on people's minds. But coming to think of it, ML is not something very new. Once I asked one of my celebrated colleagues in computer science as to at that time deep learning and all these things were coming up, and I asked her that what is this deep learning business? I don't understand anything. She said, you have done neural networks, right? I said, yeah. Okay, now you think of a bigger box with more unknowns in it, and you have absolutely no idea what's in there.
Problem. So broadly, we have in the morning we have 2 sessions before the break, and these sessions would include talks as well as tutorials today. And similarly, in the afternoon you have 2 sessions. Other than talks and tutorials, we have a bunch of things like datathon, panel discussion, early career forum, and so on, which we will introduce briefly one by one to you. And in the evening today and tomorrow we have dinner. Today it is sponsored by the director of the institute, so thank you, sir. And tomorrow we have a gala dinner. Now, a quick highlight. So we have 12 talks. They cover as much of AI as possible. But AI has become so big these days that it was very difficult to, create a bouquet of talks which give a comprehensive view. Still, we tried our best. So we have talks covering NLP, computer vision, machine learning, and so on. And also we have various applications covered for introduce what is happening in their forum. I will, before that, a big thanks to all the speakers. You will meet them over the next 2 days. Datathon, question.
Welcome everyone. So in terms of Datathon, I'm one of the organizers here. Together with other 2 people are working, Dr. Aritra and Dr. Mahesh. Briefly, this time we introduced something AI for education related challenge, and what we wanted to do that we wanted to introduce to assess how pedagogically appropriate LLM's responses are there, because people are start claiming that LLMs are doing a very good AI tutoring. So that's why we run it, okay? And in the 2 phases, 2 tracks, so there's a 2 tasks like mistake identification and location, and in the development side and the test side, okay? We'll get to know more detail on the datathon third day morning. A lot of status more. Very briefly is that we have 197 teams are registered. Out of that, we have around 400 submissions, and we invited oral and poster presentation from top 10 teams. Okay. So more detail on the 21st morning, and we give a great thanks to BEC ATAS, which is happening in the ACL 2025 because this is kind of subsidiary. Thank you.
Thanks to all the Datathon organizers. Next, we have Graduate Forum.
Very good morning to all of you. Most of the students here would have heard from me, and apologies for filling up your inboxes for the last 3-4 months. I'm one of the chairs of the Graduate Forum. So primary objective of the Graduate Forum is mainly to give graduate students, masters and PhD students across India an excellent forum to network with your peers, to showcase your research, get feedback from industry leaders as well as academicians, and obviously look for prospective collaborations and job opportunities. This year we had 230 submissions, very good quality submissions, I would say. We had a difficult time to select 70 out of them as posters. Apologies, we could not select all of them, but they are very good quality submissions, and I hope the students get ample opportunities to discuss your research with your peers and others, although not as posters. So this time we reached across 48 institutes across India, and among the participating students, 58 students are masters and 170 PhD students are participating this year. So welcome you all once again, and just going to the committee. So you all, many of you might be knowing Professor Deepanjan Chakravarti, who is a professor here only at BITS Hyderabad. Sandeepan Danpat was working with Microsoft, and now he has joined IIT Hyderabad as a professor. And Shobhata Shah is a postdoctoral researcher at MBCUI. So thank you all for your support throughout, and welcome you all once again. Thank you.
Good morning all. We started a new initiative at IndoML this year, and called Undergraduate Forum, to provide a platform for all undergraduate students to present and discuss, because AI is picking up and many undergrad students are interested in it, and build your research networks, prospective PhD advisors, and prospective research labs, as Professor Stanchu was also saying. We are starting small this time. There were 18 participants, and 6 of them will also be presenting posters, so please feel free to engage all the people in the symposium. And we have reached across 10 institutes, and please tell your friends the experience that you have had, so that we get more participation next year for the undergraduate forum. Thank you.
The chairs are here, so I will quickly introduce those to you. So the Pan India Forum is a forum where faculty from the institutes of national importance can present their work. It's a very interesting forum where we try to bring in early career researchers from all over the world covering the Indian diaspora. And the idea is that there will be a natural mixing and networking of these emerging researchers but not only the students, but also the other veterans and scientists who are in IndoML. So we received around 22 submissions, and as we go along, we will share more details. I hope you all, enjoy not only the sessions, but it also stimulates a lot of ideas and collaboration opportunities and career opportunities for all of us here. Thank you.
Thank you so much. Good morning.
First lecture.
It's a great pleasure to be here today. I basically lead a lab at the intersection of computer vision image processing with remote sensing and
University of Houston.
Right, so I decided to keep this talk at a sort of high level, give you an idea of the kind of emerging ideas in this space, and also focus it more on the nuances of the data in remote sensing. So if
Video
you're
নকৰে
interested
GoPro
in
লৈছে
this
বুজিছা
area and you'd like to
তেতিয়াহ'লে ব্লগাৰ কোন
deploy,
হৈছে
sort of the emerging
কাহিনী এনেকৈ চলে
architectures and models with such data, what are the things you need
Election.
to watch out for and consider, right? So that was kind of the thought process. What I'll be talking about, I'll give you some high-level overview of geospatial imagery, the nuances, and basically, like I said, I lead a lab in this area at the University of Houston, and it's credit-worthy. Everything you see here is work in collaboration with my current and former students, as well as some collaborators. Okay. So, if you're not from the remote sensing area, here's a bit of background about what this entails. Okay, so basically, I mean, you presumably at least know there are cameras and sensors on platforms such as satellites that are imaging the Earth over a certain temporal frequency, right? So, and then of course you've got manned aircraft or crewed aircraft and unmanned vehicles where you can also deploy these sensors and image the Earth, right? And applications are really endless, from climate science, national security, so defense applications, and everything in between. So sensitive coastal vegetation and how it's changing in response to sea level rise, right? But what you see is, despite calibrations and correcting for various factors, you can see, so these are the 10, these are the different classes that we have in this problem. Just the spectral envelope shapes for each class differ quite a bit because of differences in sensor and the viewing geometry. All right, so it's not a plug and play in terms of using these across modalities. Okay. Just as another quick example, so this is the SpaceNet 2 challenge for building footprint extraction. If you just look at one of the grayscale bands and look at the PDF, so this challenge was set up as a large data set for building footprint mapping across different cities. If you look at the distribution of the intensity profiles across cities, you can see that things change quite a bit across cities, and that makes sense, right? The way the cities are arranged are different, the dominant roof structures are different, the shapes of the roofs and such are different. So this is to be expected, and you have to contend with this, right? Okay. And since there are a lot of early career researchers here, I wanted to provide a bit of context of where this community came from before deep learning. So there's a very rich and mathematically elegant sort of set of solutions that existed up until pretty much everybody switched to using flavors of deep learning architectures, right? So basically looking at structure sparsity, data that's living on manifolds, you can model that very well. So spectral data actually does live on very smooth low-dimensional manifolds. So there are a lot of elegant solutions that existed to do feature engineering before you went this route. Okay. All right. So I won't spend much time on the basics of older architectures and simpler. I think this is standard knowledge, but I just wanted to put this here for some context. So if you're trying to use, let's say, convolutional architecture, but what you're given is a hyperspectral volume and not a color image, what would you do, right? So one thing you could do is you can learn the spectral content through a 1D convolutional architecture, for example, and combine it with 2D CNN, right? You could do recurrent, you could learn this as a time series, the spectral envelope, right? So you could have recurrent network architecture that you could combine with spatial architecture, right? Okay. So you could use graph convolutions here. They also work very well. You could think of each pixel as a node, and when you put this in a GCN type environment, it's effectively learning the manifold structure in an indirect way, and you can leverage that information. Of course, this is very intensive. You want to be smart about how you set this up. Or you could do something like a 3D CNN, where you're basically mapping, you're using 3D kernels so that you're looking at the spectral context in addition to spatial context to bring it to your learning. Right? So I won't go through some of that basic stuff, but basically our output products are land cover maps, fine-grained land cover maps, given these multimodal inputs, so hyperspectral imagery, gridded LiDAR products, and SAR, as an example. So one of the things I mentioned was there is this built-in distribution variability, right? So there are distribution shifts between training and inference conditions, and you want to be able to account for that. So one thing that you will see that, or that you would want to address, or one tool that you'd want to at least look into would be knowledge transfer learning across domains, right? So the idea is you have a domain that's data rich, where you want to do all your training, but the data where you actually want to do inference is labeled poor, okay? Just because you didn't go, you weren't able to go out and collect ground truth, okay, for various reasons. Right, so you want to, of course, do some sort of alignment of your semantic features. Let's say in this approach that we took, everything was getting aligned in a latent space through learned embeddings. Okay, through an embedding that was learned as part of an elegant mathematical formulation. So inspired by manifold learning ideas. Okay, and this works really well when you have shallow networks. So the idea was basically going from your source and target domains to a latent domain where things get aligned, right? Your semantic features per class get aligned. This works really well across a problem like this, right? As long as you're using shallow networks and you don't have a lot of parameterizations. So here's an example of that. All right, so this is for that same task of going from street view imagery to aerial imagery. These are basically showing the TSNE plots of the aligned semantic space features. In this case, this was a convolutional architecture, but you can get a fairly good accuracy when you start aligning these features across domains. Something else you can do, which would be more efficient, more effective, maybe just pick a few bands and then feed a width through it, or you could set this up in a 3D way where in addition to the traditional way of learning a width, you have the notion of a channel self-attention as well, right? So you basically are learning not just across spatial tokens, but also inter-channel relationship at the same time. All right, so we did this recently, and the results were quite promising. Next slide. All right, so this is an example of a hyperspectral benchmark segmentation task. And when you bring in these mixers that have both convolutional and transformer architectures, the results are good. But the other interesting insight, and still empirical, is that when you put things together and you combine these transformer and convolutional architectures, the lost landscape tends to be flatter, as opposed to when you're using only convolutional architectures. So that kind of hints to the fact that these are more sort of robust to perturbations. Okay. Slide. All right. So if you want to learn these through self-supervision, all right, then again the same question comes into mind. Well, how do you account for the multiple channels? Right, so in addition to doing masked image modeling, you not only have spatial masks, but you have masks along the spectral dimension as well. And so in a previous work, what we found was if you do random masking, where you're masking both space and channels, spectral channels, that does much better than if you're doing tube masking, where you're only masking out spatial content. Okay, next. I'll be talking more about this. Go on. So I'll move on to talk a bit about how can you leverage some of the recent large vision models for remote sensing. Next slide. Okay. So one of the first efforts in this space was we looked at standard diffusion models. So we started using these for super resolution, but as a side effect, what we noticed was you can actually learn the latent representation of diffusion models. These are quite expressive and can transfer to remote sensing for tasks like segmentation. Okay, and so if you have a hyperspectral volume right here, you can, for example, take the RGB, pass it through your diffusion model, and what you get is basically for every patch you get spatial features that you can then use for segmentation tasks. All right, but that's of course missing the spectral context completely because you just use RGB. So what we did was for every patch we had spectral signatures, and we did a film-style modulation of these spatial features. So this is basically a mapping that takes us from spectral envelopes to weights that can go up and down depending on what the spectral signature is telling us about that pixel or about that patch. All right, so this works really well. In a sort of a follow-up work. So in the first work, this was frozen. So we used frozen diffusion models. But in the second approach, we actually fine-tuned the diffusion as well. So forward. All right. So just to show the expressiveness of these latent features, these are just showing clusterings from a patch coming out of a diffusion network marked by using diffusion features. This actually beats fusion approaches that were even incorporating SAR for the same data set. All right. Next slide. Okay. So moving on. What has really been happening more recently are people are looking at foundation models, and this could be vision only or vision language type models. I'm only focused on vision for this talk, so because I wanted to highlight this one model and its variant that was recently released. So NASA and IBM released a foundation model for the Earth. So this is called Prithvi. And the version 1 of this model was basically pre-trained on the continental United States. All right, so what they basically did was they had a harmonized Landsat Sentinel product. Landsat is a satellite out of the US, Sentinel is a satellite out of Europe, and so these are both multispectral satellites. And basically, you do your standard masked image modeling, so you're doing the pretext modeling where you've got your input images coming in, and you're masking out parts of the image, and your decoder is trying to unmask those for you, right? And once you're done with this learning, totally self-supervised, you can throw out the decoder and put whatever heads you want there, such as object detection, segmentation, or whatnot, right? And so you can basically pretty much plug and play with this encoder. You can go out and start using it for remote sensing, right? But you'll see a couple of issues that still exist, right? So this was for an HLS product, which still is just a couple of bands, right? So it's not trivial to expand this to higher dimensions. You could do it, but then you have to bring in additional context. All right, so by the way, what I'm showing here is version 1. Version 2 basically extended this to the entire globe. So they did self-supervision over the entire Earth, and then they made some more architectural modifications to improve the performance. Next slide. Okay. All right. So you can think of VFMs to be generalists, but the question is there a need to go beyond simple fine-tuning? Okay. Next. Okay. So why would you want to consider that? Well, because there may be a significant domain difference between what Prithvi has seen, even though it has seen the entire US or the entire Earth, depending on the model you're using, but there may still be variability from the modality, the imaging modality itself, the viewpoints, Maybe you have rare events that aren't captured or represented in that existing modeling. Next. Okay. All right. And the other thing to contend with is we may not, this is a standard problem with remote sensing. Ground truth is expensive and often very difficult to get because of the terrain, for example. Right? So we often don't have enough data in the domain we want to do inference in. Okay? So one of the things we did recently that I'll show is instead of just simply finding this is a Prithvi encoder, but we've added some additional layers, trainable layers to account for the different number of channels. If you'd like to use this for a hyperspectral image, right? And then, of course, if you're doing semantic segmentation, you'll have a segmentation decoder. But then, instead of just a segmentation loss, we have some additional components. We have a domain adaptation loss. This is basically doing so you have soft pseudo-label based adaptation. So we're looking at entropy and the confidence in the predictions that are coming out as a measure of how good the learning is. And then there is a source to target MAE that's at play here, all right? So let's say you're going from Prithvi to a hyperspectral image, and within that hyperspectral sensor, let's say you have a source domain where you were able to label in a reasonable amount of pixels, and you have a target domain where you want to do inference, right? So you could set up a source to target MAE component here, right? And you could train all of this collectively. Next slide. Okay, another one. Next. Okay. Yeah. So here's an example. So this is the FLAIR data set. So it's for transfer learning, testing out transfer learning. So we picked a city in the inner parts of France as our source domain, and one on the coastal side as our target domain. And this is not the same sensor that Prithvi has seen, right? So we still have to go through that same adaptation. If you look at this first column, that's the standard fine-tuning approach to Prithvi, right? So if you just take that foundation model and fine-tune the segmentation head, this is what you're getting, all right? But if you bring in these components together, you can do much better, okay? So basically, this shows that there are built-in domain differences, and if you can account for them effectively, you can definitely do much better in remote sensing tasks. Okay? So here's another application. This is a hyperspectral image, all right? Same idea, same model, right? And what's, of course, this is the simple fine-tuning approach, and this is with everything combined, right? But what you see is this is still a very challenging task, but the interesting thing is you can actually recover the entire spectral signature of every class very, very accurately. Okay? And that's really impressive, given that Prithvi hasn't seen hyperspectral data at all. All right. Next slide. All right. So a few closing remarks. If you're considering this to get started into remote sensing, it's tempting to maybe pick the latest, greatest models and start working with them. But if you're truly going after a specific application, you may want to consider the trade-offs between a smaller task-specific model and leveraging emergent foundation models. Right? That there's value in both. Next. And while you're doing that, you may want to design the model with the nuances of the data in mind. Right? So how do you account for multiple channels? How do you account for totally different domain distributions and so on, right? And often we are not given enough high quality data. So I would argue that the quality and the quantity of the data is equally important, if not more important, than the choice of the model that you're using. Right? Next slide. Okay. And of course, this domain distribution, this domain shifts are everywhere. It's pervasive in remote sensing. You cannot avoid it. And so you have to think of clever ways to incorporate that in your design. Okay. Last slide. All right. So I'd stop here, and I'm happy to take questions. Thank you.
a task is assigned, there is a routing or a handoff which happens, and the control gets transferred to these specialized agents from the router agent, and it's taken care of it independently. These router agents also can be kind of coupled with planning, where you break down the tasks and then you route it, and that becomes the handoff pattern. Or the planning can be combined with a supervisor pattern, where after the task breakdown, the control still remains with the coordinator agent, but the specialized agents carry out the different tasks. And there are kind of iterative ways of producing outputs, which is like a discussion or a reflection pattern. You can use a workflow orchestration. So all of these patterns are possible in both these, all the design patterns we saw are possible in both these cases, but it will basically be dependent on what kind of orchestrations we are going to use. And we saw about the reflection pattern is where there is a producer LLM which is generating the content, and then there is also a reviewer LLM, and this happens in an iterative fashion again to produce the final output. The router pattern, as we discussed, is basically it's like a handoff, and where you kind of route the, depending on the specialization the agent has, it gets routed to the right agent. And planning is basically, again, breaking down a complex task into multiple and reason, and then basically use either a router pattern or agents as tool patterns. So I'll quickly walk through a code which implements these patterns in the Azure Agent Framework SDK. Just give me a minute. So the prerequisite is the agent framework installation, Azure Identity package for authenticating with these services, and also we are going to use Weave for monitoring these agents. Agent framework also has an inherent monitoring and evaluation capability, but for this tutorial we are just going to see it through Weave. And we start by giving the orchestration model. We are going to use either as a chat or a responses API, and also the API endpoint is set. And then basically we start looking at this workflows. So starting with the monolithic agents or the sequential pattern we saw, here the LLM is like the workflow is performed in a sequential fashion, the output being kind of routed, basically it's like falling step by step. And this is only useful for cases where you have linear workflows, very predictable in nature. You can use this kind of a pattern. And also we have we define an agent by using the Azure OpenAI chat client. We start with defining a chat client, responses client, and then we create an agent leveraging that client. And then basically we run the agent for a particular task, then the output flows from task from every step. And as I said, this is a manual orchestration, and this can be implemented with workflow. So workflow is a concept of agent framework SDKs where the process is very well defined, and just the steps happen one by one. It supports a diverse set of tasks, including VQAs, report generations, localization capabilities. So the LLMs localization, so the embedding from the LLMs pass through specialized vision modules. As it is generating the content, it also localizes the abnormalities, the tubes and lines placement in the patient's body, and different pathologies and devices. And in addition, the model also kind of reasons with respect to the radiology findings, connecting the patient context, radiology knowledge, because like in a medical setting, we have a lot of differential diagnosis cases. Though the symptoms present the same for different patients, there is a differential diagnosis involved depending on the patient context. So a lot of factors needs to be considered for differential diagnosis. So the model needs to reason with respect to radiology knowledge, radiographic findings, and also the patient context. to affirm certain conditions or rule out certain conditions. If there is a limited patient context, then it needs to provide all differential diagnosis capabilities. So I'll just quickly play this video to show how this model was built and how we are using agents here. And then Anirban can present how we have built the agents which you are going to see in this demo.
XR is a compact vision language model purpose-built to seamlessly integrate into real-world radiology workflows for chest X-rays. Designed for flexibility and efficiency, it supports a comprehensive suite of clinically meaningful tasks, including radiology report generation, fine-grained visual question answering for abnormalities and medical devices, and precise grounding of anatomical structures, pathologies, and device placements. A key innovation is its capability for causal exploration. The model doesn't just describe findings, but expands them into structured, evidence-based reasoning. By integrating radiology knowledge, clinical context, and differential diagnosis, RAD54 Vision CXR helps affirm findings, rule out conditions, and bridge the gap between descriptive reporting and diagnostic decision-making. The architecture of RAD54 Vision CXR is built on a streamlined, multi-stage pipeline that integrates vision and language modules for multimodal reasoning. In Stage 1, a SIGLET-based image encoder is fine-tuned on chest X-ray datasets to extract clinically relevant visual features. Stage 2 focuses on training vision-language adapters and specialized detection modules for visual question answering and localization, with the rest of the model kept frozen. In Stage 3, low-rank adaptation is applied to further enhance the adapters, the 5-4 language model, and detection modules across a diverse set of tasks. Tailored loss functions, causal LM for language, and a combination of GIOU, MIOU, L1 regression, and focal loss for grounding ensure robust performance across detection, grounding, and VQA tasks. RAD54 Vision CXR delivers robust performance across multiple benchmarks, including visual question answering, enabling radiologists and clinicians to ask nuanced questions, localize findings, and receive actionable, clinically relevant insights from chest X-rays. RAD54 Vision CXR brings agentic intelligence to chest X-ray workflows, turning a single user query and indication history into a coordinated plan of action. A planning agent routes the case through quality checks and interpretation. The image quality assessment and view classification agents validate inspiration, projection, and rotation. Then the image interpretation agent drives multimodal reasoning with the RAD54 Vision CXR model, producing findings and a concise impression. When geometry is needed, the geometry agent provides anatomical masks and measurements. When devices are present, the tubes and lines agent assesses placement and describes positions. If abnormalities are suspected, the grounding agent localizes evidence. The differential diagnosis agent adds causal exploration, linking visual cues to clinical context to affirm or rule out conditions. Finally, the reporting agent synthesizes everything into a clear, editable report, keeping the clinician in the loop. CareX agent transforms radiology workflows with agentic intelligence, providing comprehensive clinical support and enabling a context-aware, human AI collaborative ecosystem for inpatient care. Here are some examples of CareX agent powered by RAD54 Vision CXR model in action. Scenario 1, radiology report generation, causal exploration of findings, and differential diagnosis. In this scenario, RAD54 Vision CXR demonstrates its ability to generate a comprehensive radiology report with causal exploration and precise grounding of abnormalities. The clinician begins by prompting, write a detailed radiology report, provide causal exploration, and ground the abnormalities. The system analyzes the chest X-ray and produces structured findings. Next, the model delivers causal exploration summary and differential diagnosis. Causal exploration expands findings through structured reasoning, leveraging radiology knowledge, disease manifestation patterns, clinical context, and differential diagnosis. This approach allows the model to confirm observed findings or rule out potential conditions, significantly strengthening its role in clinical decision-making. Finally, the impression summarizes the key findings which are grounded in the image. Scenario?
I'm going to end this due to lack of time and just let Anirban present how we built one of these agents. We have 3 agents actually, but we will go to one by one.
and how much we
So this is your own custom-made software.
This is our course also. End-to-end in-house. Yeah. And on top of that, cloud management. First is like simple, like these are the 2 or 3 pieces.
Yes.
And then
So now the benefits for the one is any other areas? This will be connected with the how many tokens were consumed, what was the time spent on the latency values, you will be able to see what kind of inputs and outputs were passed, you will be able to see. You will also see a composition view. So suppose if you have a complex workflow, you also need to see the workflow has multiple the workflow will have multiple agents, and the agents will have multiple tools. So all of this composition view will basically help go into here there are 2 calls, so you are able to see the 2 calls which are made, and then you will also be able to see a kind of view which basically.
যেহেতু আজি আমাৰ বিটছ পিলানীত IndoML Symposium আছে 2025 আমি ইয়ালৈ আহিছোঁ অলৰেডি ইয়াতে ৰেজিষ্ট্ৰেশ্যন ডেস্ক ইপিনে আছে আৰু ইপিনে ষ্টল আহিছে নটেক্স ইপিনে নেলছন IQ ইপিনে ডলবি আৰু ভিতৰত ইপিনে লাঞ্চ লোকেশ্যন গোটেইখিনি চলি আছে ইপিনে পোষ্টাৰ সেকশন চলি আছে পোষ্টাৰ সেকশন চলিছে এতিয়া লাঞ্চৰ পিছত ধেৰ পোষ্টাৰ কান্দু মখান হেভি পোষ্টাৰ হেভি পোষ্টাৰ